Many parts of NASA's James Webb Space Telescope have spent time inside facilities that simulate the extreme environment of deep space millions of miles away from Earth where the telescope will operate. The Primary Mirror Backplane Support Structure, or PMBSS, which is essentially the spine of the telescope, just completed testing inside the X-ray and cryogenic test facility at NASA's Marshall Space Flight Center in Huntsville, Alabama. To prepare the Webb structures to meet the extreme temperatures of space, engineers at the X-ray and cryogenic facility carefully examined telescope components inside a vacuum chamber that simulates the hyper-cold of space, chilling the hardware from room temperature down to a frigid minus 414 degrees Fahrenheit. The telescope's backplane supports the beryllium mirrors, instruments, and other elements. It holds the 18-segment, 21-foot diameter primary mirror nearly motionless while the telescope peers into deep space. ATK built the backplane structure at its facility in Magna, Utah, under a contract with prime contractor Northrop Grumman. The backplane is made of advanced graphite composite materials mated to titanium and Invar fittings and interfaces. Invar is a nickel-steel alloy notable for its uniquely low changes due to thermal expansion. The backplane is the final part of the Webb telescope to complete tests in the X-ray and cryogenic test facility, one of the only places on Earth where such large components can be tested in a simulated space environment. Webb's wings underwent testing in the facility. The wings, also made by ATK, are made up of 900 separate parts of lightweight graphite that fold up, allowing the entire mirror assembly to fit inside a rocket for launch. This spring, Marshall engineers tested samples of Webb's sunshield in a smaller environmental test facility. The sunshield acts like a parasol, shading and protecting Webb's sensitive mirrors and instruments. In space, the sunshield will experience both hot and cold temperatures. For the test, several sunshield samples experienced temperatures ranging from minus 423 degrees Fahrenheit to 170 degrees Fahrenheit. Marshall performed the tests for Mantech International Corporation. The company recently completed manufacturing of full-scale sunshield test articles that weigh a mere 18 pounds, yet are almost 45 feet wide by 70 feet long. The entire sunshield consists of 5 tennis court-sized, kite-shaped layers that will be folded and deployed once the Webb telescope reaches its destination. The sunshield must endure a decade of space operations, so the sunshield material, Kapton, was exposed to space as part of the Materials International Space Station Experiment, or MISSE. The material spent more than 4 years in orbit, which helped engineers at NASA's Goddard Space Flight Center, the NASA center managing the telescope, to determine if the material would perform well as a sunshield. Marshall engineers analyzed the samples when they were returned to Earth. The Webb Observatory will be 100 times more powerful than the Hubble Space Telescope, and it will be operating farther away from Earth. NASA will not be able to service the telescope, so its parts must be light, strong, and durable. Marshall test facilities have played a key role in ensuring Webb's success.